My name is Eduardo Martinez. I'm the VP of Technology for StreamGuys. I'm joined here with my colleague Tim LaBelle, who will be helping us walk through some of this. We're going to pick it up from where the CDN and contribution network. So everything after when the encoder leaves the facility. We're going to quickly cover a couple of just streaming trends here.
So I'll cover the ad replacement, cloud distribution, and then Ed will get the more technical ones. Two trends we've seen for a while and we're still seeing is more broadcasters moving to ad replacement for their streaming. Now that might just be out of market, but with more and more listenership continuing to happen on streaming over the broadcast, we're seeing broadcasters start to realize if I just bundle this in simulcast, maybe I'm giving away a lot of the value that's in my streaming audience to just people that are, or advertisers that are sponsoring my broadcast or buying advertising in my broadcast. So we're seeing, it used to be just the largest players, but now we're seeing a lot of the medium and even smaller players in the radio space start to look at and implement ad replacement. Like I said, there's different strategies we see there. Is it just out of market? Is it everything? But identifying that those digital streaming listeners are valuable and might even be the lion's share of your listenership is something that I think is driving this. The other thing we're seeing is cloud distribution. So this is actually using the streaming technologies, including what you're seeing from the Streamblade and the Duo for backhaul, where we're taking streaming technology and using that for distribution for syndication or getting it to the transmitter, things like that. A lot of the technology can be used in this way, and we're seeing maybe concern over the long term of satellite and what's that going to look like, what's it going to cost in the next 5 to 10 years. And so we've for a long time, and still to this day, we're seeing broadcasters and audio networks start to explore what does cloud distribution look like? How can I use streaming technologies for my distribution needs in addition to streaming to the end users?
And on the protocol side, on the evolution side of it, we've seen the uptick in purpose-built protocols that are used to ensure a smoother connectivity from when the signal leaves your facility into the CDN ingest. So purpose-built protocols like SRT, which stands for Secure Reliable Transport, RIST, which is something that Wheatstone supports today, protocols like Zixi are seeing an uptick on the contribution side. Traditionally, a lot of these protocols come from the video side, but we are seeing an uptick in the use on the audio-only distribution as well. On the egress side of it, when we talk about the evolution of protocols there, ultra low latency streaming has seen a big uptick for our big sports broadcasters there. So traditionally, broadcast streaming has a typical delay of around 30 seconds by default when you're using HLS. We're seeing folks use ultra low latency streaming to bring that delay significantly down. So when you have sports broadcasters that are doing live sports and you want to be feel like you're in the stadium for your end listeners, ULLS makes that possible today. The focus of our talk today will be around HLS encoding and the various benefits that are there. So in terms of HLS streaming and why it matters, we can begin by talking about what is HLS. HLS stands for HTTP Live Streaming. It's Apple's adaptive bitrate streaming protocol. We take a live linear stream, we segment that into smaller chunks, and that gets distributed in a playlist to where each player consumes that out. We can have multiple quality variants for adaptive playback. So similar when you're used to looking at YouTube or Netflix when you have a high, medium, low, this technology is available for audio streaming as well. So you can have a higher and a low bit rate to optimize on your network conditions there. We use standard web infrastructure for delivery. So you can use a traditional HTTP content delivery network like StreamGuys. You can set up your own server if you have small broadcasters, but this is all standards based on technology that runs most of the internet today. The magic of it happens in the manifest. The manifest, that M3U8 file, is just the extension at the end of a streaming link that guides the player behavior. So for example, we talked about cutting up a stream into different chunks. Those chunks can be in different lengths. The manifest defines the size of that. So you can have a playlist manifest with live stream chunks of 10 seconds each, and there might be three in the chunk, or you can increase that all the way up to 6 segments and have longer segments. At the end of the day, that provides added resiliency on the broadcast. Why does this all matter? We have with HLS universal compatibility. So across all major streaming platforms, major devices, in this day and age, a lot of folks are supporting HLS. It also brings scalability. We can leverage typical content delivery networks like StreamGuys to do large scale distribution. So you save yourself a lot of the headaches of trying to have purpose-built infrastructure to scale your audience ship. To touch back on what Rick was talking about in terms of metadata, HLS is one of the protocols that has in-band metadata. So as each segment and chunk is being cut up into smaller pieces for delivery, the ID3 metadata is placed inside each chunk. So we don't have to do things like in the past. For IceCast, you'd have to short poll a stream and constantly, short poll the server to see if there's new metadata updates. With HLS, you get the benefit that each single chunk contains that data. So in each player implementation, you can pull that out individually. Reliability is another wonderful benefit of HLS. Using HLS, you provide seamless transition between networks. So you're in your house listening to your favorite stream, you're on your mobile phone, you're on your Wi-Fi, you walk outside, you transition to a cellular tower, that stream stays hitless and you're in tune and you're still listening to the broadcast. So no more start and stop streams when you switch from Wi-Fi to 5G and vice versa.
And if I can add a couple things here,
Most definitely.
on the reliability side, we anecdotally, when broadcasters switch from IceCast to HLS, I hear their support desk people say we get less calls from people saying there was a problem with the streaming, right? There's always some, but they get less calls. We also recently did a study too, when we've been moving customers from IceCast to HLS, we'll see that their average time spent listening actually increases by a pretty meaningful percent. We're seeing like, on average, listeners are staying connected another 5 minutes or another 3 minutes. And that's because that protocol, you can just listen to it forever. As long as you don't have long internet outages, the listeners will stay connected. They're driving around, they're switching Wi-Fi to LTE, they stay connected. So those are two real world reasons to use HLS.
Yeah, most definitely. So on the distribution side of it, there's two pieces to the puzzle. There's what we call the contribution network, which is a purpose-built. Think of it as the on-ramp to get your content into the CDN. So at that last image that Rick provided, where it says your stream is leaving the CDN, the contribution network is the path that your stream takes to get into the CDN, which in this case it could be StreamGuys, it could be everybody else. So the contribution network is making use of HLS. You can have encoders that can natively segment to HLS, and we can ingest that. So all of the reliability that Tim just talked about from the consumption side of it is also available for the contribution side of it. So when you're sending an HLS stream packetized over the public internet, and there might be a little bit of packet loss or jitter, we can overcome that, and it's a seamless experience when you're ingesting that content into the CDN. CDNs also use HLS. It's the standard, for delivery these days when we're talking about live audio there. It just all the benefits that we talked about are kind of cohesively there present. So it's a unified workflow. HLS is both on the encoding side and the public side as well.
So we'll talk.
Go ahead.
Talk about three metadata use cases here. Actually, four. The first one here is broadcast to podcast. And all of these are ways that you can use metadata to automate things downstream that happen. So if you have a live program that you want to be made on demand, well, using metadata is a very easy way to trigger the start and stop of recording, to trigger the replacement of in-stream ad breaks with podcast ad breaks. So as long as you have tight metadata in your automation system and you have a great encoder like the StreamBlade or the Duo, and you're able to pass that to your CDN, you can then use other services to do that broadcast to podcast functionality and save that production time. So this is a big deal for live content that is repurposed because it's instant and there's no production time involved. The other is ad insertion. I think this is probably of the most commercial value because it lets you do ad replacement in your stream, where if you have listeners out of market, you can replace your broadcast ads, which might be local, to programmatic or other national sales ads that you've sold. Um, and you can also replace in market as well if you wanted to. But all of that is driven on metadata. That's what lets that ad insertion timing be very tight. If you have bad metadata, you're going to have a bad ad insertion experience. And then the third one is source switching. Uh, the use case here is usually sports or other content that needs to be blacked out or embargoed, where you might have some programming that you can't stream, so you need to switch to other content. That can also be controlled with metadata. So if you're sending metadata in the stream and you have specific metadata syntax for when programming starts and stops that needs to be blacked out, you can switch to other content during that time and then switch back when that's done. And again, that's all driven off of metadata. The fourth is royalty reporting, which is a lot less fun than these, but everybody who broadcasts music in the US, for the most part, has to do this, where you need to provide a report to Sound Exchange for your streaming performances, saying, hey, here's the songs I played, here's how many people heard them. That is almost always driven off of metadata as well. So if you send the artist and title and ISRC codes downstream to your streaming provider, they can provide you with that report. But it all comes from the metadata. So it's a very important engine to all of these things that save you time and help you make more money.
Most definitely. So here we start doing a little bit of a deep dive into broadcast to podcast. We're illustrating with the diagram a live linear stream. And again, it all stems and ends and starts and ends with metadata. So we have your regular live broadcast. The broadcaster from the radio automation system sends a metadata trigger. In this particular case, we have a start and stop trigger. Let's say you want to record your morning show from 9 to 10. You put that in your clock with the specific metadata triggers that are configurable. We have a backend system that's constantly monitoring for the presence of those metadata triggers. We then have a process that segments the content out, records it into that fixed file, takes that and then can publish it as a podcast episode. This could go into an existing content management system that you have. It could automatically get published to an RSS feed so that you have a new episode, and this can happen completely automatically. So this metadata workflow saves folks a lot of time from the production side of it because you don't have to constantly, start clipping heads and tails for shows. It can be completely automated. So if you have a popular news and talk segment in the morning that needs to get published to an Alexa, daily briefing, configure a system like this with tight metadata to send stop and start signals and have the process be completely automated.
So here's a little bit more information on server-side ad insertion. Uh, as I mentioned, I personally think this is where the most revenue tied to metadata comes from. And these are high-level things that apply to anyone in the streaming space. I talk from StreamGuys perspective, but everybody does this. But at a high level, server-side ad insertion is replacing content in a stream. Now, it might be a pre-roll, might be an audio pre-roll, or it might be replacing ads in the stream with other ads, or any content with any other content. It's really just content insertion and content replacement. Now, sometimes these things are client-side, which is like a pre-roll in a player, a video pre-roll. These things are always client-side because you can't stitch a video pre-roll into an audio ad or an audio stream. But a lot of audio-only ad insertion is done server-side. And the difference between client-side and server-side is server-side ad insertion is stitched into the stream itself. So it seems exactly like the streaming content. That's why ad blockers can't block it. That's why if you listen on TuneIn or you listen on iHeart or you listen on your website, you can hear those ads everywhere because any listener that's connecting to the streaming server is getting the server-side ads. And they're all dynamic and they're all targeted to each listener. The four of us here could all hear different ads. Now, client side can be dynamic as well, but it is dependent on the media player. So you could only do that on your own website or your own app or on a media player that you control as well. Um, the other thing that's very interesting about dynamic ad insertion is the targeting and the precision that you can use when running these campaigns. So you can run them for specific geolocation, zip codes, DMAs, states, countries. Um, you can run them by device type, just Android, just iOS, just mobile, things like that. So you can get very precise on the users that you target. This lets your sales team sometimes get more creative for buyers that want a specific type of audience, as opposed to just selling a spot on your content. Now you can sell a campaign that targets their users specifically. And from what I've seen, this ends up looking more like how Facebook or YouTube or Google is sold, where they're targeting an audience. Um, Maybe it's men 25 to 50 who are interested in golf. These are the types of things you can do with dynamic audio ad insertion. Um, so it's a very interesting and deep space, and you can start to get very sophisticated campaigns with this technology. Um, Now, direct sales is always the highest value where you're selling local, but there is other elements here like programmatic ad insertion, and this is more outside of the encoder realm. This is into ad tech now, but I think for the purpose of this conversation, you just need to know that metadata needs to be tight. It needs to be there. So it all starts with an encoder that can support in-stream metadata, and keep that in good time with the audio, because otherwise this is a terrible user experience. You can't roll it out. But once you have that metadata tight and in time with the audio, it opens up a whole plethora of opportunities here to use ad technology for these interesting things.
All right, so let's take a deeper look at the server-side ad insertion process here. Again, it all starts and ends with metadata. In this particular scenario, we have a live linear stream. We're sending signaling metadata. This could be ID3 or SCUDdy35. On the server side, we're constantly detecting the presence of that metadata. Once that metadata trigger is received, we can then trigger server-side ad insertion to replace a simulcast ad, for example. The ad decision engine from there has all of the users that are connected and all the targeting data that Tim was talking about come into play with the ad decision engine that picks a specific ad to be stitched in. So we can be listening in here on the West Coast in a local DMA for a station. The ad break hits, server-side ad replacement happens, and we can get a particular ad here in California that could be a completely different experience than you would get on the East Coast, for example. You see stations targeting, in and out of market DMAs to create these very, very personalized ad experiences for your end listeners. As Tim mentioned, if your metadata is not tight, if the timing of when you send that signal is off by, half a second or a second or two, the end experience to the listener can be just very jarring, because you might either get a little bit of audio on the underlying stream, the transition is not as smooth. So metadata has to be very, very tight for the server-side ad insertion experience to be nice and fluid for the end listener. Again, all driven by metadata. If your metadata is tight, that end user experience won't be seamless. Another interesting use case when it comes to metadata is what we like to call HLS source control. The scenario here is when you have live sports, and as live sports broadcasters, it's, you have to be very adherent to the rights of the actual stream of when can somebody hear that game. Are they in a specific DMA? Are they allowed to hear that game or not? Here we can use a stream. We can ingest a primary stream with HLS. Again, we're monitoring for metadata in real time. As soon as that piece of metadata comes in to denote, for example, a blackout broadcast, to say at this specific time, you have to switch that underlying source stream to alternate content for folks that are not in the specific area where you're allowed to listen to that game broadcast. That's where we can take another HLS stream, sub that in automatically so it's seamless. So in my previous example, we were talking about ad replacement. In this particular case with HLS source control, it's a more advanced piece of kit because you're actually swapping out a full audio stream for that end listener. And that has to be seamlessly done as well. Again, driven by metadata. What happens if your metadata is not tight coming from the encoder? What could happen is, you miss the start of the game, or you're streaming part of that game to a person who's not supposed to be listening to it because they don't have the rights from a sports streaming perspective. All of this is seamless and dynamic and fluid because we're using HLS as the core technology to swap out the stream for the other alternate stream. And then finally, this is an overarching view of the contribution network here that I'll let Tim jump into. But hopefully this is a wide overview of kind of how all the pieces of the puzzle fit. From the left-hand side for the source contribution side of it, from a stream blade, powered by, super tightly aligned metadata. That'll feed into the rest of this workflow here. But at the key, we'd like to say that, if content is king, metadata is certainly queen, kind of driving everything behind the scenes and making these workflows happen.
Yeah, so this contribution network diagram, the goal here is to help put this in perspective for you on where all of these components live. For this diagram, we have a camera here, but that just, that represents the streaming encoder. Could be a Duo, could be a Streamblade. And we can receive a whole variety of streaming protocols, all standards-based, nothing custom for us. And that goes into the contribution network. Now, the contribution network can receive HLS. There's lots of benefits to receiving HLS in the contribution network, but it does a lot of potential transforming of the content or automating other processes of the content before it gets to the delivery side. So that might look like transmuxing if we need to change between protocols. This happens often if you have an IceCast encoder, but we want to deliver HLS to the end user. We'll transmux from IceCast to HLS. Maybe, in the video workflows, we'll push to social media, or we send a video feed to social media. We could transcode. So if you're sending a high bitrate AAC and you want that transcoded into something else, that's doable here. It's always best to send everything that you want delivered to us in that native format. But if you can't do that, transcoding is an option. Translation of ad markers. Again, this is maybe more of a video workflow where you're looking at receiving SCUDdy35 and you want that to be ID3 or vice versa. That happens in the contribution network as well. And then some of the other automations that we're talking about here, like turning a podcast into on-demand content, that happens in the contribution network. And then the content delivery, this is separate. So it could be a third-party CDN, or it could be us, where we're delivering those streams to the end users in HLS, ideally, because we have all of that resiliency that we talked about. The metadata is kept very tight. And that's where the ad insertion or the geo-blocking or things like tokenization for content protection happen. They happen on the delivery side. So this just helps you understand the framework of where things come from and where they go.